Welcome. We'll be looking at a data set, which is the NASA surface temperatures data set, and we will be just practicing our data munging skills in basic Python code. We're not using any fancy libraries here. We're just using basic Python functionality to open up a file, look through the lines of the file, cut up the data into a usable form, and save the file as a CSV so that you can then do some follow-up work with that. There is an analysis part of this workshop where you're going to open up that CSV you made and loop through all the lines, add up some data, and come up with some simple statistics. So that is the key concept here. You're going to be munging a data file, which is sort of preparing the data to be ready to be analyzed, and then performing some analysis. And this is to get your comfort with data, to get your comfort with Python, to build up your skills and confidence levels. And then we'll get into, of course, more advanced stuff at a later date. So let me kick into the workshop concept. You guys have a link. What you'll get when you click that link is something like, you are accepting this assignment. What is your group that you want to join? And at this point, you don't know what your group is, but you will see an existing group name if one of your teammates has already done this, or if you're the first in your team, just type in the team name down here. So pick a team name. When you have a group, pick a team name, one word, keep it simple, and you can all plug it in and you'll all be in the same repository at that point, meaning you're all sharing the same code on GitHub at that point. All right, so that's what it's going to look like when you click that, and that's what you're going to do on that screen. Now, let me get into some of the nuts and bolts of the actual assignment. In the repository that you will have created automatically on GitHub, when you click that link and plug in your group name, you'll get something like this. And there are instructions here. So you're going to have a link to click the instructions. And here is pretty much everything you need to know about what you're supposed to be doing, right? So this is the full assignment. The full workshop is outlined here. Let me just run through that for a second. I'll skip part 0, which is figuring out how your team is going to work together. We'll come back to that in a second. But the big picture idea of the workshop, you're going to download some data. In this case, NASA's surface temperature analysis data. There's the actual data file linked down here. This is just a site about that data. This is an FAQ page about that data. Here's the actual data, so you can click through and get the data. This is a fixed width column text file. Remember, good for print. And your job is to make that good for a computer program analysis. In other words, your job is to get this in CSV form, comma-separated values, which is a standard form for this kind of data, where instead of spaces between each data point, you've got comma. You're going to be using basic Python skills to do that. You're going to have to chop off, some of this text that isn't the actual data, keep the heading line, and then keep all the lines as they are here, but replace these spaces with commas, all of them, and get rid of these extra spaces and these extra heading lines, which you don't need, and chop off some stuff at the very bottom as well. You also need to figure out what to do with some missing data. So there is missing information here. The stars indicate data that is not available. They didn't collect it or it just wasn't available for some reason. I think that's the only place. That's the only year where there's missing data. Often there's missing data in various data sets. Your job is to decide what is the appropriate action to take on that missing data. In some cases, you want to just replace missing stuff with a 0, if that makes sense with the data. You have to know what this column means in order to decide whether that makes sense. In some cases, it makes sense to put an average of other data points that you have in the missing spot. So if it's a missing spot that you don't know what the value is, you might average other related values and just use the average, kind of plug in a best guess at what that value might have been. In some cases, your best option is just to invalidate this entire record and say, if we're missing that data, we can't use this record. It's not going to keep our data valid. So your job is partially to discuss that amongst your team and decide, which is the best option. So that's the idea of the data set. You're going to have to, munge it, clean it up, put it in a CSV, figure out what to do with the missing data, remove some of the excess stuff. The second part is, making the CSV. I've already mentioned that. And then you have to do an analysis. So you're going to write a Python program named analyze.py. And by the way, the munging part where you clean up the data is going to be put in a file named munge.py. And I've given you those files, actually. So if you look at the file structure that I've given you, you have analyze.py and munge.py already there. So you just have to go and put the code into those two files. All right, so analyze.py, you're going to do some analysis of this file. You're going to open up your nice clean CSV file, which I'm asking you to call cleandata.csv. You're going to import that into Python, and you're going to get the average temperatures, the average temperature anomaly in degrees Fahrenheit for each decade since 1880. Here's the data. You've got decades of data. Like this is the first decade from 1880 to 1889. This is the second decade, the next 10 years from 1890 to 1899, right? So I'm asking you to output the average temperatures by decade. They're giving you average temperatures in some cases by year and actually by month as well. And I'm asking you generalize that, put it into decade averages. So it makes it easier for us to see some trends in this data. You're kind of lumping together some cohorts of years. You are allowed, when you're doing the analysis, to use a CSV module, which, if you remember, opens up CSV files and makes it easy for you to flip through the data in a CSV file. But when you're talking about the munging, I'm asking you not to use any libraries like CSV or pandas or JSON modules. But with the analysis, you are able to use just this one module, CSV. No pandas, for those of you who know pandas. And that's it. You're going to submit your work using Visual Studio Code. You go to the source control tab in Visual Studio Code. You enter in some message like finish the workshop or whatever. And then you click the dots up here and you select the push option. And that will shoot the code up to GitHub, and that's your submissions. Remember that one of our ways of kind of looking at data is the smell test. Does this data make sense? There's this sniff test or smell test that you often do as part of your kind of validation of the data. And you might say, that doesn't make any sense, right? Negative 17 degrees, even Celsius or Fahrenheit doesn't matter. This still wouldn't make sense, right? However, bear in mind that you do have some documentation on what these numbers mean. And part of that is here. I mean, this is in degrees Celsius, first of all. Actually, not in degrees, but in 0.01 degrees Celsius. So this is a fraction of a degree Celsius in the negative. And this is not actually a measurement of temperature. This is a measurement of, well, you're going to read the documentation to some degree, but this is a measurement of temperature difference. So I will let you guys look at that and kind of understand that. But this is showing you anomalies. They're actually showing you here that there's a base period, which they consider 1951 to 1980. So they've done some math to say, okay, what were the average temperatures for each month from 1951 to 1980? And they're telling you how far off the temperatures were in each of these months in each of these years. So this is the difference from the base. The base is the average of temperatures from 1951 to 1980, and this is the variation, or what they call the anomaly, from that base period. So you see that mostly it's negatives, compared to that base period. And then it kind of gets lower and lower negatives. They get, lower and lower negative numbers. And then you hit around the 0 mark, and then you start to see positives most of the time, right? And then bigger positives most of the time, and then even bigger positives most of the time, until we're in more recent years where we have far more positive anomalies. In other words, the world is getting warmer, right? Or whatever you want to say, you've just proven, if you believe NASA data, if you don't think it's fake news, you would have just proven to yourself that global warming is happening. Didn't take you more than probably 5 minutes of looking at this data to determine that. Now, whether this data is accurate, let's not go there. So that's the idea here. You're doing some stats on this very public, very well-known data set. Now, let me jump into how you do this as a team. So I've written another document, which is in your repository code. It's called how to work in groups.md. It's in your file list, but there's a link to it as well. So how to work in groups. And there are 3 different ways that I am asking you guys to work. You can choose for your team one or a combination of these 3 ways. You could have one person as the dedicated code writer and the others as advisors and helpers in real time. So that's a real time at the same time, where one person's writing the code and everybody else is just talking and giving advice and helping that person write the code correctly. Right? So the person who's writing the code isn't making all the decisions. They're just doing what the will of the group says to do. And people are helping each other, figure out the best code, and that person is the one actually doing the writing of that code. Right? That is the easiest, most straightforward way. But let's say this is the fallback option that is always going to work, doesn't require much technology. All you need is some kind of screen share. Another option is where all the team members are actively writing the code at the same time. Whereas this one is just one person writing the code. This is everyone writing the code at the same time. That sounds like a disaster if you have a lot of people, but with 3 people, it should be manageable without too much, people writing over each other's code. So to do that, you would want to use a real-time collaborative code writing tool. And Visual Studio Code, our editor of choice in this class, provides a tool like this, where one person can start essentially like a share code session. It's kind of like a Zoom chat session or something, but it's about code. And everybody else using their own computers on their own Visual Studio codes can log into that person's Visual Studio Code and start to adjust the code on that person's machine. I'll show a little example of this in a second. So that's option number 2 for real-time collaboration, where everybody writes the code together and actually writes the code. Whereas this one is one person doing dedicated writing, other people just talking and giving advice. The third option, and this is for everyone who is purely asynchronous, who has no option of being synchronous at any time. I don't know why that would be, but if you refuse to do any synchronous work with your team, this is your option. And you would do so asynchronously using Git and GitHub, which we're all using anyway. And there's a specific workflow that I have outlined below that will help you do this work in an asynchronous fashion without overwriting accidentally other people's code. You're all working on the same file. There's a big chance if you don't do it this way that you will accidentally overwrite someone else's work when you change a file. So if you follow a very specific workflow, this is an easy enough thing to do. All right, so let's talk about the dedicated code writer. That is the first option. I've gone into each of these in a little more detail. I don't think there's much more to say about this. You do a screen share. The person who's writing the code does a screen share. You all talk on audio chat, on Zoom, just regular microphone Zoom chat about the code that person's writing. And you all just do it together, but that person writes. So that is option number 1. Option number 2 is real-time code collaboration. And what I mean by that, everyone writing the code at the same time in a single editing environment. So you're not all using your own isolated Visual Studio codes without seeing what the other people are doing. You're all in one environment on your computers. It's kind of like a chat system, but instead of sending messages, you're sending code, and everyone sees what everyone else has written. Visual Studio Code has a live share extension pack. Let me jump into that and just show you how that works. So I've got Visual Studio Code open. In Visual Studio Code, you have a marketplace, I think it's called, or extensions building block, kind of an icon on the left. You can click that, and you can search for Live Share Extension Pack. And by Microsoft, who make Visual Studio Code, there is this Live Share Extension Pack. So click that. Up at the top is a button to install, and it'll just install itself into your Visual Studio Code environment without any fuss. So that's the first step. Just get this extension installed, extension pack. It's actually a set of extensions. Once you have that installed, which I already do, you then have on the left a new little icon that you probably didn't have before called Live Share. So if I click on that, there is an option to start collaboratively editing and debugging others in real time. So there we go. You can set up essentially like a chat kind of session, but with code as the thing that's being chatted. So let me click that button. I'm going to click Share. Share Now, I guess, is the button I want to click. So you need to sign in with Microsoft or GitHub. Microsoft owns GitHub, so it's kind of the same thing. So I'm going to sign in with GitHub because that's, I think, the best option for us. So sign in with GitHub, just authorize that extension. It asks you if you want to pop open Visual Studio Code. So click yes, you already have it open, so do that. Click yes to allow that to open up a live share session. And now at this point, I hope, there we go. On the bottom right, it tells me a couple things in these little panels on the bottom right. The bottom one is the one that popped up first. So invitation link copied to clipboard. Those of you who have Visual Studio Code installed and have just installed the Visual Studio Code Live Share Extension Pack will be able to click that link. You're going to go to a page online on the web somewhere. It's going to ask you if you want to pop open Visual Studio Code, say yes. And you will be now in a collaborative editing environment with me on my machine, essentially. And at that point, you are able to edit the files on my machine. You're editing code in my folder that I have open in my Visual Studio Code. You can flip between all the files in the project. You can make new files. You can do pretty much whatever you want on this project. So this is how I suggest you all try to do the work in the beginning. And this might go haywire. It may not just you may have technical difficulties. Some computers may not do this well. You may find that having 3 people writing code at one time is just too much, craziness. In which case, just go to the first idea, which is just do one person writing the code, but the other people all kind of just chatting about it. And when you're done, whichever way you do the code, of course, you submit. You go to your source control. If this is not a repository, but you add a commit message. You do the instructions of how I said to shoot the code up to GitHub. So that's all in the instructions. Before we do anything else, let's flip to the third way of doing work, which is purely asynchronous with no real-time collaboration, no chatting in real time. The big idea here is you've got a repository, you will have a repository on GitHub that your team all shares. And the idea here is whenever a teammate begins working on the code, they first download anything that's new on GitHub to their own computers, and only then they begin working on the code. So every time you start working on the code, first download anything from GitHub onto your own computer. Make sure you have the latest from GitHub on your own computer, and then start your work. Anytime you've made significant changes, you've done some code that you think is worth sharing with others, you're going to upload your changes to GitHub. So you're going to shoot your changes up to GitHub, and then other people will download them next time they work on the code, right? So anytime anyone does any significant changes, they're shooting, called pushing their code to GitHub, and other people are downloading it, called pulling it to their own computers before they work. So that way everyone's always working from the latest code that everyone else has shared up on GitHub. In order to do that, you're going to have a remote repository, which we already will have. You're going to have to clone that repository to your own computer. That's pretty easy. You can, in any project on GitHub, like this project for me, there is a code and a clone kind of option. Copy that link by clicking the button. Go to Visual Studio Code, make a new project, and go to the File Explorer, clone repository, paste in that URL, clone from that URL, put that there, and it'll ask you where you want to save it, and you'll have your repository in your file system at that point. So that's how you'd clone. I didn't follow through on that because I already have done it, but that's how you're going to clone. You're going to go to the repository, click this, copy that link, go to Visual Studio Code. You can just go to Source Control, or you can just go to the File Explorer. Either one will show you an option to clone a repository here or here, and just paste that in again and clone from that URL. So that will create that repository on your own computer. You've got a copy of that code on your own computer at that point. Now, the next step, so once you have that, that's just a general project set up, and then you go into the day-to-day or moment-to-moment workflow. The first thing you do in a project is a git pull. Let me pop open the version I already have. The first thing I would do if I was going to start working on this project would be to go to Source Control and do a pull. That's downloading the latest code from GitHub. So any changes other people have made and put up there on GitHub, I'm getting those now downloaded onto my own computer. Then I would go and do my work, make my changes that are solving the problem, doing whatever I need to do to get the assignment done. And when I'm done, save the file, go here, enter in like finished part of it, whatever, some message that tells people what you did. Command enter to on Mac, or Control Enter on Windows would do Git operations called adding and committing, which in the instructions are outlined, and then a push to shoot that code up to GitHub. I'm not going to do these because I don't want to mess up my project, but you would make your changes, add some message, Command Enter on Mac, Control Enter on Windows, and then push. And that shoots up your code to GitHub, and you're done. You've shared your code on GitHub. Other people on your team who are going to start work later are going to download that, and they'll have your latest code in that way. And that's it. You just follow that until you're done. It is possible in some cases that Git will notify you that you have a conflict. So that would happen when you do the pull. So if I go and I do pull, and let's say I've edited analyze.py and someone else has edited that same file in a way that is conflicting with my change. When I do a pull to get the project from GitHub, or it could happen when I do a push, but when I do a pull, usually I will be notified that there's a conflict. And what Visual Studio Code will do, it'll actually, in the editor, if you go down to Source Control, there'll be an area here called like Merge Conflicts, and it'll show you which files have, two developers have done conflicting code in. And you would have to go in and manually edit those files to make sure that whatever code is in there makes sense. You maybe delete some of your code and keep some of the other person's code, or delete some of the other person's code, keep some of yours. Do whatever you think makes sense, because the computer can't figure out how to do that for you. You've got to kind of have your personal outlook on that and decide what to do, and then just you commit it the same way you would normally do. So that's the way it's going to work. There's going to be an indication in the actual code, like it'll have some lines like, here is Bob's code and here is Amos's code. And I would have to go in and cherry pick some of their code, some of my code, and manually figure out what is the right code based on two different people's sets of code.